Alrighty, so second part of our vocab. So we've done area, right? We talked about irregular figures. Those are kind of fun, I think. But anyway, moving on to surface area. So what I want you to think about are boxes, right? Or cans. We're looking at the outside area of 3D figures. Not all it's inside yet. We'll get to that. But we're going to do the outside area. So surface area is defined as the sum of the areas of all the surfaces of a solid figure. Now, you can use these weird things for a formula. That's fine. We'll talk about that. S is surface area, B is base area, P is perimeter of the base, H is height, C is circumference. Something to remember is the measurements are in square units. We're not doing volume. Volume is cubed, but this is just a bunch of squares or circles and squares and rectangles and stuff added together. So it's still just surface area, so it's still just squared. So here's pictures, again, of the different pieces, just to give you the idea what we're talking about here. So rectangular prism, notice they call these lateral faces. The sides are lateral faces. The top and bottom are called bases. Now, if you laid it on its side, you'd get something similar. This would be like a Pringles can, the one on the right. So bases are the circles. The lateral faces, now this is important, lateral face, because I'm going to ask you for that in a quiz or test. What is the lateral surface area? So the really cool thing is, you'll see in a little bit, this actually is a rectangle. We'll start out with a prism, and that's the first day's homework. The second days will be over cylinders. But a surface area of a prism, I give you sort of a formula here, 2b plus pH. Here's what I really do. Add up all the surface areas. So imagine a box like this. There are 6 sides, front, back, top, bottom, left, and right. And the dotted line obviously shows what's behind there, right? So surface area, this has 6 sides. Notice I can fold it out to something flat called a net. 1, 2, 3, 4, 5, 6. 6 sides, top, bottom, technically front and back, left and right. So we make it flat. I'm pretty sure you probably saw these last year. Today we're going to actually do something with them. There's a handout that has this picture on it, and it has like a few others. Go grab that. It's part of your notes. It goes along with today's homework too, whichever day you happen to be on here. Because this video, you'll have to decide how far you want to go in it, depending on what day you're in. So, but again, notice here the idea of a 6-sided figure: top, bottom, left, right, and front and back. And it looked like I clicked on the same thing twice. I kind of did the way this looks here. But again, it folds out. Here's the left and right side. Here's the top, bottom, left, and right kind of thing. So going all the way along here. Actually, probably top, bottom, left, and right. But so anyway, again, a handout for you. Kind of shows how these things break down. There's one with triangular prisms and one with cylinders in it too. So on the same sheet here, you can see the triangular prism. The front and back are triangles. That's here. And this one has 3 sides to match. 1, 2, 3. This is the one along the flat side. Or, well, one of the sides. It doesn't really matter. One of the sides here, and then the others kind of lay out. So, again, make sure you grab a copy of this handout. It'll help. So when I ask you for the surface area, you'll find the area of the 2 triangles. And you'll find the area of each of the rectangles. And in an equilateral triangle, this works out pretty well. But it's really easy. But sometimes it may not be. Okay, so again, we're finding surface area, and we talked about the fact that this has 6 sides. So, the great thing is with rectangular prisms is they come in pairs. They come in pairs. So, let's talk about the 6 sides. Let's talk about the top and the bottom. Here's the bottom. Let's talk about the top and the bottom. Again, there's the top. There's the bottom. So, let's talk about the top and the bottom. That is 45 by 36, and I actually like to draw these out. To draw out my pretty pictures. So 36 by 45. And this is where you grab your calculator. That's not a very good 5. This is where you grab your calculator and you go ahead and multiply it out. So 36 by 45 is 1620. And there's 2 sides like that. So multiply by 2, because again it's top and bottom, and that gives you 3240. Okay? Then in addition to that, we have the sides. So we have the left and right. So this side and the one you can kind of see through the rectangular prism here. That's 54 by 45. So I'm going to draw that out. I'm going to draw 54 by 45. And again, just use your calculator to multiply that out. That's 2430. And times 2, because there's 2 of those, right? There's a left and a right. So that's 4860. Okay? And then there's one more side, or two more sides I should say. There is a 45 by, no, we did 45 by 36. What do we do? 54 by 36. There we go. We have a 54 by 36. And on here, that is going to be the front and the back. So here's the front, and you can see the back through it. So that's 54 by 36. I'm going to show you something else here real quick. So 36, 54, and you multiply that out. And that's let's see here. No, that is 1944. And obviously multiply that by 2, and we get 3888. 88. Boy, that's just, I have to get a nicer pen for this. All right, let's try that again. So that is 3888. Now all we do, so we've multiplied off first, right? So we started out each of our three types of sides. There's two of them, and so we're just going to add that together, and that comes out to be, magically enough, 11988, and that's inches squared because it's area, not volume. It's area. So we've added all 6 sides together. Now I promise to show you a little more of a trick to it. So if you struggle with a rectangular prism, trying to see all the 6 sides, there's 3 sets of numbers. There's 54, 45, and 36. So 54 times 45 times 2. 54 times 36 times 2. 45 times 36 times 2. So basically you're going to use each number twice and then double it, right? So notice the 36 appears here and here. Notice the 45 appears here and here. And the 54 appears here and here. So basically with a rectangular prism I use each number twice, then double the result and add it together. That's kind of the cheater's method if you struggle seeing some of the sides. So again, this would be a nice example to go ahead and put in your notes. So you might want to do that. Write out all the stuff here. Now sometimes I'll give it to you flattened out already. So here, notice I have 1, 2, 3, 4, 5, 6 sides. Huh? You like that? So now what I like to do with these, I'm going to expand this a little bit, make my life easier. So I have 2 of each side, right? So you can go through and multiply them out. And then we're just going to add it together in the end anyway. So we'll start out with, over here, 6 times 9. Just a second. So again, we'll start at this side, the 6 by 9 over here. And 6 times 9, we all know, is 54. So 54. We have 2 of those. This over here is the same, 54. Then we have right here 30 by 6. Well, that is 180. And we actually have 2 of those. This one here as well. Then we have 30 times 9, which is 270. That's what this one is too, 30 by 9, 270. Now you just add them all up. So we add up the 54, 54 and the 54 and the 270 and the 180 and the 270 and the 180, and we get a grand total of 1008 meters squared. So I kind of like it when they're broken down flat. I think it's easier to see them. So there you go. Another good example. Put it in your notes. Now this isn't a place where you pause and go to class K. This is a pause, so if you don't want to move on to cylinders, you can do that part tomorrow. If you want to finish up cylinders, you can, absolutely. But I'm not going to do any homework from cylinders today. That will be tomorrow. So you could pause here and come back to it tomorrow, or just keep going and finish up your notes. So again, back to this idea of the polyhedrons here. We just did this, right? 6 sides. And if you pause and this come back second day. Today we're doing over here, doing cylinders. And again, just surface area. And let's talk about that here. Surface area of a cylinder is technically 2 bases and CH here. So 2 circles. And I'll show you a picture of that. And CH is the area of the rectangle that is created by cutting the sides of the cylinder and laying it out flat. And I'll show you that in the next picture here. So here's the net of a cylinder. Notice again the top and the bottom of the can, right? And then this is a rectangle. If you rolled it back up, right, folded these in and rolled it back up, you would end up with this rectangle wrapped around the outside. So there's nothing magic about it. But here's something I want to show you. This side length right here is identical to the distance around the outside of the circle. So technically this part right here is made up of the circumference of a circle. So this is the circumference, so this long side here equals the circumference of the circle. Okay? So same thing up here. This one is equal to the circumference of the circle. The height is the height of the can. That's not going to be any kind of big deal at all. So this one does have a real nice and tidy formula. Okay, I like this one. What it is surface area of a cylinder, 2 pi r squared. Remember, a circle is pi r squared. That's the surface area of a circle. Well, I have 2 of them, so it's doubled right here. Then 2 pi r h. That is technically this distance, which is the same as around here. So along the side, normally a rectangle, we'd say, length times width, but we don't have length. What we have is this side, which is the length, which is identical to the distance around the outside of the circle, which is the circumference of a circle, which is pi diameter, right? So, or 2 pi radius, remember that formula? And then we go ahead and multiply by the h to get the rest of it. So, again, if we take a look here, radius here, height here, 2 pi rh is this length along this side. So again, a nice simple formula. I don't know if I can make you memorize it, but I'm going to make you use it. So again, surface area of a cylinder, write this one out. Now before we start, I want to talk about some of the parts of this. First off, obviously the radius. Now if you don't see that, we can take this and we can turn it sideways, right? So if that makes you happier, we can most certainly do that. So there we go. So now you can see the radius right here, 28, height of 60. That's all we really need to be able to fill in. So I'm going to follow the formula. And if you remember, we talked about in terms of pi when we discussed the circumference and the area of circles. So we're going to talk about the same thing here. Now our answer we're going to land at with decimals, I'm sorry. But I do want to talk about in terms of pi and show you how that works, because I'm going to expect you to do that. So, alrighty, so let's fill in the numbers that we know. 2 and pi are numbers already, so we can leave that as 2 pi. Radius is 28, so 28 squared. Plus, again, leaving 2 pi there. Radius, again, is 28 times the height of 60. So you find those alongside here, 60, right? Okay, now if I'd have given you diameter, by the way, you would just cut it in half to get the radius. Don't forget that. Alrighty, so let's go ahead and multiply this out. I'm going to square that 28, so that's going to be 2 pi. 28 squared is times 784 plus 2 pi. I'm going to multiply the 28 and 60 out and get 1680. Now I'm going to go back and multiply the numbers. So 784 times 2. 784 times 2 is 1568. And still bringing along that pi for the ride. Don't lose the pi. Plus, and over here we're going to do the same thing. 1680 times 2. So that's going to give us 3360. And again, bringing along that pi for the fun of it. Now that we have pi here, we don't stop. Technically, since they both have pi, I now am allowed to add them. So I'm going to add 1568 and 3360. So that's going to give me 4928. And then again, pi is just coming along for the ride. Technically, if I said leave in terms of pi, you would stop here and label it as inches squared, because again, it's still just area. So if I said leave in terms of pi, you'd stop there. But if I didn't, you would multiply 3.14 times this. So 4928 times 3.14. And you would get this lovely answer down here of 15,473.92 inches squared. So there you go. And it's not a bad idea to work it like you're going to leave in terms of pi in case I say it and you forget it. And that way you've got both answers and you're covered. Alrighty, this is the end of the vocab, the second part of the vocab. We'll do volume in a few days, but this is the end of the surface area stuff. A couple of nice examples you're going to want to write down. And again, make comments in your notes about here. Right? This is in terms of pi. In terms of pi. Pi is Pi, by the way. No E. If it was E, it'd be delicious. Okay, thank you very much.